Good morning, my dear students. I hope you all are doing very well. Today we will learn the concept of chromophores and auxochromes in ultraviolet and visible spectroscopy. The term chromophore is basically formed by two different words, chroma and phore. Chroma means color, while phore means anything which produces something. So it means producing something. So chromophore means producing color. Any group which can produce color is known as chromophore. But this is an old definition. Earlier it was believed that all groups that impart certain color to the solution are known as chromophore. For example, nitro group, since it imparts yellow color, it is believed to be it's considered as a chromophore, and of course it is a chromophore. But this definition is quite specific because there are certain groups that do not absorb, that do not show any color in the ultraviolet or ultraviolet region or visible region, but they have a characteristic absorption, and even though they are not colored, but they are chromophores. So this definition was quite specific, and therefore the current definition, latest definition of a chromophore is that it is an isolated covalently bonded group that shows a characteristic absorption. In UV visible region. UV visible region means 190 to 700 or up till 800 nanometer. If they show any characteristic absorption, so we call that group as a chromophore. I once again tell you the definition. Any isolated covalently bonded group that shows a characteristic absorption in the ultraviolet or visible region is known as a chromophoric group. This is the latest definition and quite broader definition. Now, according to this definition, various groups such as ethylene groups containing CC double bond, acetylene groups containing CC triple bond. Then we have a very important class of chromophoric groups which are known as carbonyl groups, and carbonyl groups are present in acids. They are also present in esters. They are also present in aldehydes as well as ketones. So my dear students, these are some of the very important chromophoric groups which are very prominent in ultraviolet and visible spectroscopy. In addition to these groups, nitrile group containing CN triple bond is also a class of chromophore. Then in chromophore, the two types of transition, because these CC double bond, CC triple bond and CO double bond, they show two different types of transition. One is known as the pi to pi star transition and the other is known as N to pi star transition. Although all these compounds containing carbonyl group shows both these transition, pi pi star transition as well as N to pi star transition, while the ethylene and acetylene chromophores have only pi to pi star transition because they do not have any non-bonded electron, and since they do not have any non-bonding electron, they do not show any N to pi star transition. So this is the concept of chromophores. Let us move on to auxochromes. So auxochromes, they also are made up of two words, auxo and chrome, which means, because auxo means enhancing or increasing. So auxochrome means they are color enhancing group. This definition, according to the definition, we can say that any isolated covalently bonded group that do not have its own characteristic absorption in UV visible region, but if they are present, they shift the characteristic absorption of a chromophore towards longer wavelength. They increase the color towards higher wavelength. Such groups are known as auxochromes. So, by definition, we can say that any isolated covalently bonded group that do not have a characteristic absorption of its own in ultraviolet and visible spectrum, visible region, but if they are present, what they do is, if they are present, they shift the absorption, or we can say, because it is denoted by lambda max, of a chromophore towards a longer wavelength. Towards longer wavelength. Clear? So these groups do not have their own characteristic absorption. The examples of this group include hydroxy group, alkoxy group, then we have NH2 group, even amine group do not have any absorption, characteristic absorption, therefore they are under the category of auxochromes. Then SH, IOL4, these are the groups that do not have their own characteristic absorption. But if they are present, they shift towards the red side, towards the longer side, because red is at the extreme right end of UV visible region. So this is the concept of auxochromes. Together, these two terms, chromophores and auxochromes, are very important, and they only decide the absorption of a given molecule in ultraviolet and visible spectroscopy. Then there are certain other terms that has to be clear before going through the types of band and before going through the Woodward-Fieser rules for calculating the lambda max for a given set of compounds. So these terms include, the first important term is known as bathochromic shift or effect. Bathochromic shift or effect means the shift of an absorption maximum or the shift of a characteristic absorption of a particular compound towards higher wavelength, towards longer side. Okay, if for example the compound is having lambda max at 300 nanometer, and by incorporating certain group we get an absorption band at 350 nanometer. So this change from 300 to 350 means that the absorption maximum has shifted by 50 nanometer towards the right side, towards the higher side. So we can say that there is a bathochromic effect or bathochromic shift. Generally, because of the presence of auxochrome, because I just told you that auxochromes shift the absorption maximum of a chromophore towards higher side, so we can say that presence of an auxochrome causes a bathochromic shift. So generally, auxochromes causes bathochromic shift. Certain other factors are also responsible for a bathochromic shift. For example, changing the polarity of a solvent, that may also cause bathochromic shift. Then we have hypsochromic shift. This is exactly opposite to the bathochromic shift. Hypsochromic shift means shift of absorption maximum towards lower side, towards lower wavelengths, shorter wavelength. Shift of lambda max, because absorption maximum is known as lambda max, towards shorter wavelength. Here we have shift towards longer wavelength. This is also known as red shift because we have red color at the extreme right, while we have a blue color in visible region. We have with your violet, blue, green, yellow, or red. So red is at the extreme right, while violet is at the extreme left. So bachromic shift because it is shifting the wavelength and lambda max towards right side. So it is also known as red shift. While auxochromic effect or auxochromic shift, because it is shifting it towards the shorter wavelength, it is known as blue shift. Then there are two more effects. It is known as hyperchromic effect. When color becomes intense, so this increases the intensity. This chromic word here refers to the intensity. So hyperchromic effect means when the intensity increases. So we can say that there is a hyperchromic effect. Intensity means, because we always in UV spectroscopy, on x-axis we have wavelength, lambda, on y-axis we have intensity of transmitted light. So if intensity of transmitted light increases, for example, by doing, we have this spectra for this absorption band for a particular compound, and by doing certain, for example, changing polarity or any other thing, we got peak at the same position but with a more height. Then we can say, since intensity has been increased, a hyperchromic effect has been observed. So hyperchromic effect means increase in intensity of a band, while hypochromic effect means a decrease in intensity of a band. These are four very important terms: bachromic or red shift, auxochromic or blue shift, hyperchromic effect, and hypochromic effect.